All right, so we are finishing up the very last thing in the chapter today, and it is called Electron Configurations. And what we're going to do is go from orbital diagrams that we finished up with last time to electron configurations. And this part people generally like because they're pretty easy to do. So the last time I did any kind of lecture, I talked about oxygen, which has 8 electrons. And I drew the orbitals out. I drew them, they can either be drawn, remember, as lines or boxes. I chose lines, and either half arrows or arrows represent the electrons. And if the half arrows or arrows are going in opposite directions, that means the electrons have opposite spins, and you can have 2 electrons per orbital, as it says with the Pauli exclusion principle. Okay, so the only difference between this oxygen and the last one is I put the 1s orbital at a lower spot than the 2s and the 2p lower still, and then I did a 3s here. And so if you look at this, we have energy of the orbitals going up. Okay, so I put 2 electrons in the s orbital. That orbital is then filled. I put the next 2 orbitals in the 2s orbital. That orbital is now filled. And then I put 1, 2, 3 electrons in the 2p, and then the 4th electron, to make electron number 8, I chose to put in the leftmost box. It doesn't matter. And the 3s orbital is here unfilled. There's nothing in it. And these are half filled. Okay, so for what it's worth, these electrons that are together in orbitals are called paired electrons. Paired, those guys. And this guy. And these ones that are alone in orbitals are called unpaired. We saw that on the video the other day, but just so you know the difference between paired and unpaired in picture. Okay, and then I think the last time I said we could write this down in a shorthand, and this shorthand is known as the electron configuration. So I can write 1s2, where this 2 means 2 electrons, which can come from this orbital. And then I write 2s2. This says the 2s orbital has 2 electrons. There they are there. And then 2p4. The 2p orbital has 4 electrons. 4 electrons. 1, 2, 3, 4. And I'm done. And I don't say anything about the s orbital because, well, we don't need to fill it. We've only got 8 electrons. We would have to get these guys all the way filled before we went into the s. Now, how do we decide which orbitals are of the lowest energy? This diagram is in your book, and it shows the 1s orbital down here having the lowest energy. See, energy. And then the 2s orbital is obviously of higher energy. And then the 2p. All right, they're pretty easy to tell apart. And then the 3s is of higher energy than the 2p. And then you get to the 3p. You're okay. And then what happens next? You go to the 4s or the 3d? Well, the 4s is of lower energy than the 3d, so we'd fill that first. But after you get to that, it's impossible to tell what comes next. It's really difficult. So instead of using this diagram or trying to memorize it, we've got a couple of different things we can do. We can look at the periodic table. Whoops, if I can pick one up here. Okay, and the periodic table has different blocks in it. These 2 columns here are called the S block, right here, across here. This is called the P block. It is 6 elements wide. This is called the D block, groups 3 through 12. It's 10 elements wide, and the F block is 18 elements wide. 18? 14. Okay, I knew that. So, if we're looking at oxygen, which is way over here, we'd put an electron in the 1s orbital. That if it was just 1 electron in the 1s orbital, it would be hydrogen. If we put 2 electrons in the 1s orbital, it would be helium, and we'd say that's 1s2. If we went to lithium, we'd have 1s2 filled already, and we'd go to the 2s, 2s1, 2s2. This is the P block over here, so boron would end with 2p1, carbon would end with 2p2, nitrogen would end with 2p3, and oxygen would end with 2p4. This would be 2p5, 2p6, and then after fluorine, or excuse me, after neon, atomic number 10, you'd go to atomic number 11, sodium. That's where the 3s orbital is. So we'd go 3s1, 3s2, bop over here to aluminum, 3p, et cetera, 4s. Then you go to the 3d, because that's what the rules for quantum number tells you. That's what the rules from quantum numbers tell you about where the d orbitals start. This one is kind of tricky to use. So instead, there is this little diagram. And you guys are going to probably pause your screen now and copy this diagram exactly the way I have it. You're going to draw 1s, 2s, 3s, 4s, all the way to 7s in a vertical column. Then in horizontal lines, the 2s and the 2p will be in the same line, 3s, 3p, 3d in the same line, 4s, 4p, 4d, 4f in the same line, until we get to the bottom. This is going to tell you how many electrons will fill the s orbital. This will tell you how many electrons. 6 will fill all of the p orbitals. You can put 10 electrons in the d, 14 total in the f's if they're all the way filled, and you're going to draw these arrows. An arrow going through the 1s from the upper right to the lower left, through the 2s, upper right to lower left, 2p, 3s, again, upper right to lower left, 3p, 4s, upper right to lower left, etc. But you're going to make this exact diagram, and then we're going to use it. So draw that now. Okay. So you've already drawn the diagram, you've unpaused, so you've looked at the energy levels from the textbook. That picture is in your book. How are you going to remember it? We can use the periodic table like I showed you. That's a little tricky. Or we can use the little triangle. All right? And what you're going to do with that triangle is after you've drawn the arrows, you're going to follow one arrow, then you're going to go to the next one down. You're going to follow it from the head to the tail. The next one down, follow it from the tail to the head, rather. Okay, so let's try this. Suppose we have boron. It has 5 electrons. So I know the 1s orbital is going to hold 2 electrons. The 2s orbital can hold 2. The 2p can hold up to 6. So following this order, I'm going to go 1s, 2s, 2p. So I have 5 electrons. I have 1s, 2. That means I have 3 electrons left. 2s, 2. That means I have 1 electron left. 2p, 1. 1s with 2 in it, 2s with 2 in it, 2p with 1 in it. We're done. Okay, let's look at fluorine. It has 9 electrons. 9 electrons, we're going to go 2 here, and we can fit 6 in the 2p. That's 10, so that's all we're going to use, are those 3 orbitals. So 1s will hold 2. Then we go to the 2s. That will hold 2. 2s, 2. Then we go to the 2p, because these guys are always in the same orbital. With 1s2 and 2s2, we used 4 electrons, and we have 5 electrons remaining. We can put up to 6 in the 2p, but we don't have 6 of them. So it looks like that. Now, actually, if you're looking at the 2p orbitals, 2p, we've gone 1, 2, 3, 4, 5. 4 of them are paired. 1 of them is unpaired. Okay, let's go to magnesium. It has 12 electrons. Well, we said we could only use, 2 electrons, 4 electrons. This is 10. This S will hold 2 more, would be 12. So 1s2, we took care of that one. It's filled. We have 10 left. 2s2, we have 8 left. 2p can hold 6. We have 2 left. And the 3s can hold 2. We've used all the electrons. So again, we followed the arrows. 1s has 2 in it. The 2s has 2 in it. The 2p has 6. The 3s has 2 in it. Now suppose we have to deal with something bigger, vanadium. Well, okay, we already know this order, so let's at least go that far without putting any electrons in it. 1s, 2s, 2p, 3s. Let's see what comes next. Okay, we did 1s, 2s, 2p, 3s. Ooh, now we go to the 3p. And then we go to the 4s, because we're following those arrows. And let's jump out one more just in case. So we're going from the 4s to the 3d. Let's see if that's enough orbitals. Okay, remember, the p's can hold 6, the d's can hold a maximum of 10. We've got to put 23 electrons in orbitals. So we write 1s2, and we're down to 21 electrons. We write 2s2. We are down to 19 electrons. The 2p's can hold 6, so we write 2p6, so we're going to subtract 6 from that. We have 13 electrons. The 3s can hold 2, so let's subtract 2. We're down to 11 electrons. The 3p can hold 6, so we say 3p6, and we subtract 6 from that. We have 5. The 4s can hold 2, because all s orbitals can hold 2. Subtract that. We have 3 left. That means there are 3 electrons going in the 3d. So we say the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. 3d3, excuse me. And those numbers up there, those superscripts, add up to 23. Suppose that's too much to write. We can do this thing called a noble gas shorthand. What you're going to do is choose the group 18, or noble gas element, that is closest to the element you're looking at, and is the one preceding it. You put the symbol for that element in a square. So He is the noble gas right before boron. Okay, here are the noble gases. Boron's here, but helium is the one preceding it. We put helium in a square bracket. That took care of 4 of boron's 5 electrons. Helium fills with the 1s orbital. So then we write 2s2, 2p, 1. So up here, this business, the 1s2 is helium. So it doesn't seem to save you a great deal with the smaller things. With fluorine, what did I just do? Helium is here. Ignore that. Helium doesn't have 4 electrons. Okay, we're going to ignore all of this. 2 electrons. Forget you ever even saw that. Helium has 2 electrons. Fluorine has 9. So after 2, we're going to write 2s2 and then 2p5. Yeah, it doesn't seem to be a real winner. Magnesium. The noble gas before magnesium is neon. And then if you look over here, you have magnesium. So instead of 1s2, 2s2, 2p6, we can write any in square brackets, and then we can just write 3s2. With vanadium, the noble gas before it is argon. It has 18 electrons. It's way over here. So we're going to go with argon's 18. Then you've got to go down to 19 and 20 with potassium and calcium, and then into the 3Ds with vanadium. So this is where this is where argon stops, right here. So we are replacing this with argon in square brackets. Then all we have to write is 4s2, 3d3. Now, I don't care if you learn this way. It's in your book. Some people find it easier. I just care that you can follow this diagram and go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, etc., 4f14, and just follow the arrows. So that's all you need to be able to do.